there anything we can do to that top term, that top polynomial, the x squared plus 3x minus 4? You can do quadratic equation. What else can you do? You can factor it, okay? Which one's probably easier for this one? Does anybody know? Factor? Okay, you can do quadratic equation. You're going to get the same answer. But just for what we're doing right now, let's just go ahead and factor it, because I tried to pick an easier one. But that being said, a problem like this is similar to what you'd see on the test. So it's not like I'm going to start easy and these are going to get dramatically harder or anything like that. This is kind of what you see is what you get for this, which is good. So you understand the difficulty level of what's going to be on the test. Okay. So first thing we're going to do is factor it. Again, you can do quadratic formula if you want, but let's just factor it for now. What does this factor to? Does anybody want to help me out with that? Yes, go ahead.
-1, 4.
Oh, I was under her. Okay, sorry. So x minus 1 and x plus 4, you said? Oops.
I don't remember.
You said -1 and 4, I'm pretty sure. Okay. And then we're still dividing this by x minus 1. Okay, so this top part, this numerator here, is all based on stuff that you've learned in intermediate algebra. All right, so to factor this, again, you can use quadratic formula, or you can think of two numbers that multiply to get this and add to get this. And that's why Scott said -1 and 4. And then you just kind of put it in there. Now, if you expanded out this red highlighted part, you would get this top part. So we're just kind of working backwards, going this way. But if you multiply the x minus 1 and x plus 4, you would get where you started, right? All right. What can we simplify with this? What cancels out here?
The x minus 1.
Thank you. X minus 1 cancels, and you're left with your answer to be x plus 4. Okay? Which is awesome. I'm going to show you another technique that you can use that would solve this, and the technique that I'm going to show you also works on other problems. This problem works specifically well because it factors well. But what if it didn't factor? Okay? If it didn't factor, then you have to use the new thing that I'm going to show you. So again, in the past, everything's factored nicely. And you might be thinking, why am I doing it this way if I just figured out another way of solving this? Because the way I'm going to show you will work for any polynomial. The way I just showed you right here only works if it factors. I'm going to show you one that works no matter what. So this is where it's kind of a review of old school long division, which actually I said middle school was the last time you saw this. I'm pretty sure it was elementary school. Okay, you probably haven't seen this since elementary school. So I'm actually going to start with numbers before we divide by polynomials. What we're going to do is I'm going to just, it doesn't really matter what number I do. Let's just do 15/2. I'm going to show you this with numbers first, and then I'm going to show you with polynomials. So we're going to do very basic numbers. You're going to think this is like elementary school all over again. And I'm meaning to do that because literally it's the same algorithm that you learned a decade ago. Actually, I don't know when you learned this, to be honest, but all right. So 15/2, if you did this as a mixed fraction, do you remember learning that in middle school and then never seeing it again? Yeah. What you can do is you can think 15 divided by 2, the lowest possible number without going over, or the highest possible number without going over, that you would multiply this 2 by, would be 7. So 7 times 2 is 14. So you accounted for 14 so far, but you still have 1 extra. So what you can do is put the 1 up here, and then it's 1/2 because it matches the 2 here. And the 7 times 2 is the 14. You don't really need to write this down because it's very basic. But yeah, 14 here, and we want 15, so you subtract 1, and that's how we got the 1 here. Okay. Do you remember the mixed number thing? Does that make sense what I just went over? Okay. And you don't have to know this. Definitely don't write this down, but it might ring bells if you think about it, where you had to like multiply this 2 by 7 and get 14, and then you had to add the 1 up here to get 15. And then you're dividing it by whatever's here to get the 15/2. So you can go forward and backwards with this. Again, we're not doing that in this class, so I'm just showing you how this is related to what you've done in the past, and it's technically the same thing. Okay? All right. So now I'm going to show you with a long division like what I was saying before. So we're going to do, I'll do purple stuff. We're going to do 15 divided by 2. You guys remember this symbol? Yeah. We're bringing it back. We have to. I'm sorry. Okay. Bear with me on this. This is going to be a deep dive here. I'm going to zoom in so we're not looking at anything else. All right. So the way to do this, and try to pay attention to it. This is not something you can just like write down. Like the only way to really, I mean, I guess you can write it down, but the easiest way to learn this is just doing a bunch of examples. So that's what we're going to do here. You have to think, just look at this first value, this leading term, this 1. What can I multiply by 2 to get that 1? Are there any whole numbers that I can multiply by? No. So what do I do if anyone remembers? Go to the next number, 15. So what can I multiply 2 by to get something close to 7, to close to 15? It's 7. Okay. I mean, I also wrote 7 and 1/2 before, so it's not, that shouldn't be a shock. Okay, now from here, I'm going to multiply the 7 by the 2, and you're going to get 14. Hold on, let me get rid of this because I don't like it there. All right. Okay, there we go. 14. Okay, we're going to subtract the 14 here, and then you get a little 1 on the bottom here. Does anyone remember what that's called? Yes. Remainder. Does anyone remember that? That's old school. Okay. They probably didn't tell you this for whatever reason, but that remainder you can put up here and then you're just dividing by whatever's here. So it's really remainder 1 out of 2. And if you notice, you get the same thing, right? Remainder, that's throwback for sure. Yeah. So that's your remainder. Now in elementary school, you usually would write this as 7 remainder 1, or sometimes you did a lowercase r, but really it was 7 with 1/2. That's what it shows right here. So I just basically showed you a bunch of different ways of doing this, but this long division thing that I just showed you, this is what we're going to be using today. And it's the exact same rules. You look at the leading term, what do you multiply it by? You have to subtract it at the bottom to get the answer. Okay. Now, if you're wondering where this algorithm came from, someone way smarter than me came up with it. Okay, because it's like, how did someone know if you multiply this and you subtract it off? Like, where did that all come from? Well, it came from this here. And you don't need to know where it came from. I don't want to get bogged down on the details because then we won't be able to solve any of the problems. But just long story short, where that came from, somebody invented that technique, that long division algorithm, that process that you're doing. Okay, so now what we're going to do is that purple, this thing that I'm highlighting right here in green, the purple thing that I divided by with that division bar, it's called, we're going to apply that concept to this crazy thing up here. Here we go. So let's rewrite this. And again, we're following the same rule. So I kind of want that on the screen still. But we're going to do x squared plus 3x minus 4. And we're doing that division bar, which is different than the square root. Sometimes people do the square root symbol. Really should have came up with a different notation for that, mathematicians. But they didn't. All right. And then we're dividing this by x minus 1. Okay, we already know the answer should be x plus 4. Okay, and again, that works because it factors. We're going to get x plus 4, but eventually we're going to do ones that don't factor. So again, please take this seriously because you're going to need it. I did not space this out well enough. That's okay. I'll just zoom out. No, I'll zoom out when we need it. Okay, sorry. All right, like I said before, you're always looking at the leading term. In this case, our leading terms are always going to be x's. Okay, so I want you to think in your head, what do you multiply x by to get x squared? What do I multiply x by to get x squared? X, thank you. Good job chiming in. That's awesome. Okay, then what you do, you have to multiply that x by these two things here. So you're going to get x squared minus x. Now, if you notice, we have two things here where before we only had one. We just had that 114. Because we have two things there, we don't want to mess up what we're subtracting. So I'm going to put a parentheses here. I highly advise writing this down. Remember, you can use your notes, and using your notes on this is going to really help with the process. So make sure you write this down. Use parentheses. Absolutely, absolutely use parentheses on this. Okay, if you picked the correct number up here, that leading term will cancel. That will always, always happen. Okay, and then you're left with a minus minus, so we're going to do plus plus. Okay, and then now we have to simplify here. We have 3x plus x is 4x, and then the negative 4 just kind of drops down here. Okay, is everyone still on board right now? If you are confused, just tell me what color you're confused on so I can explain it. Okay, let's rewind. Go over this all again. Do not write this down. I just want your brains for right now. Step 1, write it down with the division bar. Okay, step 2, make sure you figure out what do you multiply this by to get this. In that case, it's the x. Okay, Then once you do that, you can write down x squared minus x because you're multiplying it by this right here. You subtract, make sure you use parentheses, because if you don't, here, actually, let me show you what happens if you don't use parentheses. Okay. If you don't use parentheses, what ends up happening is you still cancel this out, but people ignore this. Students ignore that and they go, oh, 3x minus x, that's 2x. But if you remember the first time we did it, if you look at your paper, it was 4x. So you need the parentheses, long story short. Trust me on that. Okay. Parentheses, so now it goes plus, plus. So now it's 3x plus x is 4x minus 4. Okay. Hopefully that makes sense. Okay, now you have to think, again, look at the leading term. What do I multiply this leading term of x by to get 4x? Just yell it out, we're all friends, go ahead. Thank you, 4. Okay, so now you can multiply this 4 by this x minus 1, and you get, check this out, 4x, I should have done that in blue, 4x minus 4. Okay, parentheses, again, and watch this. What do you get for your remainder?
0.
0. Okay. And then if you notice, the answer that we got matches exactly with the answer that we got originally. Okay. I'm just showing you a different technique. And the reason why I'm showing you that different technique is because eventually you're going to get ones where you can't just factor it out and divide things out. Okay. No, the answer is x plus 4. I'm sorry. The remainder is 0, yes. And sometimes the question will be, what is the remainder? And you would say 0 for that. But the solution is the x plus 4. Okay.